My goal today is to convince one person in the world that flakiness in the world of test automation is something that now can be addressed in the front end code in literally seconds, as opposed to having an automation engineer spend hours trying to fight it. So today I want to talk about why this happens, what has changed with AI, and frankly, why any organization that still has flakiness either just is ignorant to it or is too lazy to mix up the roles and try to figure out how to address this. Okay, so before we get into it, like what is flakiness? What is this? And like why am I talking about this? So at its core, flakiness is when you run a test and it fails for not a bug, right? And there's all kinds of definitions of what is flakiness and why is flakiness and all kinds of other things. So the common couple high level, most common scenarios. One is when the browser is interacted with before it should be, or some version of that, and Playwright has a quote unquote move too fast. And so then the browser breaks. And then the second would be like data based flakiness when there's bad test data and stuff like that. In terms of this video, I want to specifically focus on the quality of the front end code and not talk about the data. That can be a separate video. But the most common sort of answer to flakiness is to do a bunch of like waits or load states or all kinds of other things. You end up writing so much code to try to wait for things to be visible and all these other things. And for a long time, I think that made sense because addressing this stuff was so tedious. Trying to get consistency in the front end was so tedious. And like your highly paid front end devs, like it wasn't worth their time to go through and fix it. But frankly, in the world of augmented coding and AI, flakiness is something that like it takes exponentially less time just to fix the front end code and make it stable than it does actually do it. And so I want to step back for a second though and talk about my perspective as a QA and engineer and now like full stack developer and how it's changed. For a long time, I just thought flakiness was like part of Playwright. It was part of automation. If you wrote automation, it was too fast. It was just always going to be flaky. And over the last 6 months, my eyes have been completely opened to when I do my own development, Playwright's not flaky. Then I go do automation on other people's apps and Playwright becomes very flaky. And then I sometimes do development in my own app and like it flakes and then I fix the front end code and then it doesn't flake. And it's like this light bulb went off like a month ago in talking to my clients about this of, okay, so what are the 10 most common reasons why Playwright flakes? And I was going to go through some of that. The most common would be something loads and shows as interactable on the page before it should be interactable, right? Playwright interacts with it, the data isn't loaded. Order of operations with loading, like race conditions, all kinds of different things. And frankly, when you look at a page object model, you'll end up seeing a bunch of things like having awaits and wait for network idle and all these other pieces, when the reality of it is it's actually just faster to fix it in the front end code now itself. And so why is this happening, right? Like continuing down this route, I think it happens because they're like two separate divisions in many organizations. So they know of each other's pain, but there's just not a ton of interest in fixing it. So like Playwright runs on the front end, right? But traditionally speaking, and here's my little guy of upset and lots of money burning it on QA. But traditionally, Playwright is managed by, let's have the person. Playwright is managed by, this could be more fun, the QA engineers, right? So Playwright is managed by the QA engineers, and their job is to make sure Playwright runs and is not flaky, etc. The front end is managed by the developers, and they're doing down here, right? And frankly, most front-end developers don't really care about Playwright and whether or not it's flaky because that's a QA problem. They just ship the feature and stuff like that. They care about code standards because like their boss is going to make them care about code standards. But there's a level of meticulousness and detail that frankly to a human, it works. The code base works. And I think this is kind of the root of it actually as I'm saying this out loud. From a human perspective, the code is good enough. From a Playwright perspective, the code is not good enough because Playwright is basically interacting with the browser extreme speeds with very specific order of operations it's doing things. And so for a long time, this QA engineer had to just deal with it because they could not touch the front end code and they didn't have the skills to touch the front end code. And so what you would do is you would have things like, I will throw it up here. You would have your sleeps. You would have your wait for network idle. I can't spell. You would have wait for requests. you would have all kinds of things like assert things are visible and blah, 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 all kinds of things. And the reason is because the loading state, there's all kinds of videos about like how front ends load and the order of operations of load. But frankly, all of those things are band-aids and they're all cost tons and tons of money. But it didn't necessarily make sense traditionally to go to front-end engineers and be like, hey, you guys need to make this whole thing a lot more stable so then the playwright can be written a lot faster, because that also cost all kinds of money. And then we introduced this idea of AI, right? And AI and what does it change? And frankly, one of the things, as much as you can debate the efficacy of AI, that it's very good at is tedious work and tedious things. And one of the things that is very tedious about browsers is the order of operations in terms of loading and how all of this works, right? And so when we're doing this with a lot of organizations, we now either have one of two things. We either now have policy of code standards that basically look for load states, and policy as code is essentially just a set of patterns that you're enforcing in the code. And then the second would be sometimes even just having QA engineers fix the front end themselves. But it's as simple as just starting by saying, if we just went and we just simply looked, right? And obviously this is not what you would necessarily do, but we'll say, look in the front end code for any loading order of operation issues that will likely cause flakiness. And while it's doing that, like basically what I want to talk about is, and why I'm saying it's lazy, is it's lazy for one of two reasons. One is your org either is clinging to these job titles and these roles in a way that I think is very quickly falling behind. So you're not going to let your quality engineers just update the front end code, even in like super minimal ways like loading. Or your front engineers just truly do not care about the costs involved with trying to write and maintain test automation, and they're just going to keep shipping it. Both of those are lazy outcomes of this, right? The not lazy outcome of this is to just spend a couple minutes and do a handful of things. One is go through your existing code and identify what are the patterns that you would identify are like the top 10 like flaky patterns. And I actually was thinking maybe I'd do like a checklist or something with this video, but it's buttons that like you can click and then like still are clickable, or things that load and show as interactable on a page and are not interactable because the rest of the page hasn't loaded, or all kinds of other things. And like, once again, you could use ChatGPT to generate 10 of these. It'd be very easy. You should just use any kind of data. The second piece is to write a set of rules, which we call policy as code, which is essentially like linting on steroids, but it basically looks for patterns and anti-patterns. And these are peripheral to tests. These are like very similar to tests, but they're less about like unit tests or integration tests, and they're more about checking for patterns, right? And checking for loading and stuff like that. That'll clean up a ton of it just by determining what are all the patterns that you need consistent across every one of your pages, and then implementing it. And then the last piece is like when flaky stuff happens. So for example, let's imagine you have a drop down or something like that, and somehow that snuck through. Having the quality engineer just be able to update the front end code to be less flaky themselves, as opposed to having to then go back to a front end engineer, have them do it, and so forth. And like, frankly, it is so much faster now for a good quality engineer who actually understands code and can do stuff to just update the front end than it is to spend legitimately like hours sometimes trying to get Playwright to behave consistently with bad code. And I think that this is that lesson, right? Flakiness for a long time was treated as a necessary evil. It is no longer a necessary evil. It's just an evil that you're too lazy to address, which is sure. I guess if you're in an organization where they truly won't let you do it, like I think your organization's being lazy, you're not being lazy. There's some other situations just to be aware of, like third-party libraries and stuff like that. Component libraries sometimes will have some flaky things. Those are like truly out of your control. I would argue more and more third-party libraries that like have a lot of the built stuff are actually becoming problems because you can rebuild most of those libraries, like component libraries and stuff like that yourself. And now you have complete control over all of the code, as opposed to like exactly at a situation like this where you've used like a third-party library. You pull in a dropdown, you can't actually see the code and interact with it. And you can, by the way, see with AI, right? It went through the code base, it's going to find it, right? The key thing here is you don't turn this into like fixes right away. What you do is you say, write me a rule that will look for this pattern throughout the code base and then find all the instances of it, right? So you create static checks for it. That's a very quick video. Once again, my goal with this video is to not change the world. I just want one organization who is dealing with flaky tests right now to recognize that like you shouldn't be. That was solved probably 6 months ago in terms of AI's ability to fix a lot of this stuff, like with a prompt. And either your org is being lazy or frankly, hopefully this is a wake up call. If you want more of these videos, you want more detail, happy to get into it. This is maybe more of a rant than anything, but hopefully it's useful. You can check out more of my content on LinkedIn. My name is Ben Fellows. I run a company called Loop QA. You can check out our company at workwithloop.com. And yeah, don't forget to like and subscribe. Appreciate it. Talk soon. Bye.